Let's see what a black body is. When we simply define a black body, we can state a body which absorbs all radiation falling on it is called a perfect black body. As just now we have studied, when say some radiation incident on a body, a part of it is absorbed, which is written as EA, the energy which is absorbed is EA. A part is reflected due to the nature of its surface, which is ER, and some energy is transmitted across the body, which is ET. So, if ER is equals to ET is equals to 0, then the body is termed as a black body. It is generally considered that when a surface is black, it does not reflect any radiation. In parallel, for an ideal or a perfect black body, we consider that it will not also transmit any radiation through it, and whatever energy is incident on it, that will be absorbed. So EA is equals to EI for a black body. In nature, no available bodies are perfectly in black, but the emission increases up to as much as approximately 98 to 99% of the incident radiation, which you can simply state a black body which exists in nature. But for an ideal black body, we consider it as a body which absorbs 100% radiation which is incident on it. There are lot many natural bodies which can be considered as a black body, like charcoal, a rough surface which are painted black are also considered as black bodies. So we can state as a black body is a very good absorber of thermal radiation. So it must also be a very good emitter of thermal radiation according to Kirchhoff's radiation law. That means if there are two bodies at same temperature, one is a black body and other is a general body, then black body will emit maximum radiation compared to any other body. So we can state all black bodies are a very good emitter of thermal radiation. Now another important term which is used to analyze radiation of a body is called emissivity of a body. Now for a general body, it is defined as, it is denoted by a letter small e, which is written as a radiation power emitted by a body divided by the radiation power emitted by a black body at same temperature. And here we must consider that this black body is of same geometry as that of this body, and radiation power is the amount of energy emitted per second. So it is quite obvious that just now we have discussed that black body is a very good emitter of thermal radiation. So black body at a given temperature will emit much more heat compared to a normal body. So we can simply state this emissivity is always less than 1 for general bodies, and this is a factor which we can state account for all the factors related to thermal radiations for a body surface, that how much close it is to black body. Like we can simply state for a black body, E can be written as 1 because this is the maximum amount which the black body will radiate. And for any body which is having the value of E which is close to 1 can be approximated as black body, and if it is far less than 1, we can simply say the body is far away from the nature of black body. Similar to this emissivity, we define another term which is absorptivity. And this term emissivity as well as the term we are going to discuss, absorptivity, play a very important role in analysis of thermal radiations which are absorbed or emitted from different bodies. We'll see in coming slides. A term similar to emissivity is absorptivity of a body, and we can state for a general body, it is defined as A is the ratio of radiation absorbed by a body to the radiation incident on the body. Like if there is a body on which the total radiation energy which is incident is Pi, that is the incident radiation power, the amount of energy which is falling per second, out of which the energy which is absorbed by the body per second is Pa, then we can simply write A is equals to Pa upon Pi. Or this can also be written as radiation absorbed by a body divided by radiation absorbed by a black body if same radiation incident on the black body. So we can state black body will absorb all the radiation which is incident on it. So it comes out to be the same ratio. So we can state here for black bodies A is equals to 1, and for general bodies A is always less than 1, and we can simply state as good absorbers or good emitters of heat. So for bodies which are having high value of emissivity will also have high value of absorptivity. So the numerical value of absorptivity and emissivity can be taken approximately equal or in similar range for most of the bodies. So we can state bodies having high emissivity will also have high absorptivity, and similarly those bodies having low emissivity will also have low absorptivity. That is simply as per the Kirchhoff's radiation law, which we have just now discussed in previous slides.